We're interested in the smallest three-digit positive integer which can be written in the form p q squared r, where p, q, and r are distinct primes. So we need to be systematic with this. The smallest primes are 2, 3, and 5. So if I start with the smallest possible value that we could get, and let's go from there, I'm going to get 15 times 4, 60. So that's too small. Now if I stick with 2 for a little bit, maybe I try 3, and then the next one, 7. That's still going to be too small. It's going to be 21 times 4, 84. So maybe 2 squared times 3 times the next one, 11, would work. That's going to be 132. Okay, so at least I've got a three-digit number now, but is there anything smaller? I don't need to go any higher with the 3. I want to stick with the 2 squared for the moment, but what if I try the next ones up? So 5 here, and then let's go back to 7, but it can't be the same as 5. So I'm going to get 20, I'm going to get 140 here. So I'm still winning with 132. So I think I've exhausted all possibilities where I have a 2 squared. Okay, because everything else is going to be bigger. So now I'm going to draw a line under that and look at 3 squared. So 2 times 3 squared. And if I start with the smallest one, 5 again, I'm going to get 10, I'm going to get 90. Right, I'm going to stick with the 2. Sorry, I'm going to write it. I don't know why I'm writing it. I'm going to put the 3 squared first. Just a bit easier to compare. Okay, let's stick with the 2, but now go with 7. So that's going to be 18 times 7. That's 70 plus 56. That's 126. Okay, that one's winning now. And if I go, yeah, I'm not going to try any more with that one. So 3 squared times, I'd have to try a 5 now. And then times by 7. That's clearly going to be bigger. Okay, so I don't even need to calculate that. And so I've exhausted all the ones with 3 squared. That leaves me 5 squared. So if I go with 5 squared times 2 times 3, that's the smallest that it could be. I'm going to get 25 times 2, 50. I'm going to get 150. And so I can see I found the smallest one. It's got to be 126. So I hope I've convinced you of that. I think just be really careful, systematic. I worked my way through the 2 squareds, found all the different ones I could, then through the 3 squareds, then through the 5 squared. All the other ones would be larger. This must be the smallest possible one. And interestingly, like it is actually then, if we write them in order, 2 times 3 squared times 5. I don't think we could use that, necessarily. We were not told that Q was bigger than P, but it ends up being that way.